Here we go. So you can get rid of a square root. First of all, it has to be all by itself, because if you square a side that isn't all by itself, you're going to have to FOIL, and it probably won't get rid of it. But if it is all by itself, like this root 5x is all by itself, you square both sides, then you get 5x equals 100, and divide, and you get 20. Now, sometimes questions will ask you to verify. When they ask you to verify, they want to take your original equation and split it up. What was on the left side, what was on the right side? Well, the right side was 10. The left side started with the square root of 5x. Plug in your answer that you got, and simplify both sides separately. Of course, the right side was just 10, nothing to do. But if they work out to the same, then you've verified it. And the interesting thing that's going to happen with square roots is sometimes you will get answers that actually do not work, which is weird because you solved it, did what you thought was mathematically correct the whole time, and you got an answer that actually isn't an answer. They've got a fancy name for it. It's called an extraneous root, but we'll get to those in a bit. So if we were highlighting stuff, oh, I shouldn't have highlighted. Here we go. Nope. How about that one? There we go. I guess this is the one. A radical equation is when you have an x or a variable inside the radical. So these examples that we're going to do in example 1 are called radical equations. Okay? So you have a radical equation. You need to, like, the shortest way that you could say the strategy is you need to isolate and square. Is the term with the square root by itself? Yes. Okay? And sometimes people wonder, well, I could divide both sides by 4. Perfect. You could do that. I'll show you what would happen if you did that. Or if you just said, well, the term is by itself. What if I square right away? Now, if I square the left side and I square the right side, I'm going to put the right side in brackets because that whole side will get squared. The left side, 3 squared is 9. And in your head, remember that squaring is multiplying by itself. Okay? And so what do we get? We get 4 squared is 16. Squaring gets rid of the square root sign. Okay? So we get 16x. Okay? Last, to get x by itself, I would need to divide both sides by 16. So I get 9 over 16, which is done. Okay? If you had decided to divide both sides by 4 to begin with, totally okay, because in equation solving, you can use all the rules that you've had in the past. What you do to one side of the equation, you can do to the other side of the equation. And then I square both sides. Squaring a fraction means multiply by itself. How do I multiply fractions? Multiply the tops, multiply the bottoms, and you would get the same answer. Okay? Now, technically, root x times root x would be root x squared. And when we square root an x squared, we should put the absolute value. But since this one is only defined when x is bigger than or equal to 0, I can just write x. Okay? Sometimes you just write x. like this, and it's when you verify. So in the verify, we write left side, right side, and draw a line in between. On the left side, we started with a 3. On the right side, we started with a 4 and then a square root of x, and now I would plug in 16 over 9 for x. The square root of 16 over 9 is the same as the square root of 16 over the square root of 9, so that would be 4 and 3. Did I make, oh, it's 9 over 16. Wow. I was like, oh, it's not going to work. Well, it doesn't work if you verify and plug in the wrong number. That is for sure. This is 9 over 16. So square root of 9 is 3. Square root of 16 is 4. This would be 4 over 1. These 4s would simplify. And that is what verify means. We plug it into the left side. We plug it into the right side. We work separately on those sides to see if they're equal in the end. So now we know that 9 over 16 works. Part B, 13 equals 2 root x plus 1 minus 7. Solving a square root equation. Isolate and square. Is the term with the square root all by itself? No. Number one mistake in solving a square root equation is squaring too soon. We cannot square both sides yet because the term with the square root is not isolated. What could I do? I could add 7 to both sides. And at this point, you've got choice. The term with the square root is isolated. You could square both sides. You could also simplify because there's a 2 in front. In this case, I think I would simplify that 2 in front, right? The opposite of multiplying is dividing. And so it just gives me smaller numbers if I simplify. Divide both sides by 2. I get 10 equals the square root of x plus 1. And now I've isolated my square root. I can square both sides, and I get 10 equals x plus 1. Subtract 1 on both sides, and I get, 10 squared is 100. Thank you. Look at that. Subtract 1 on both sides, and we get x is equal to 99. Go to verify, left side over here, right side over here. You go back to your original equation. So in your original equation, you had 13 on your left side, and we had the square root of x plus 1. So now I can plug in the 99 plus 1 minus 7. This will be square root of 100. I missed the 2. And you would get 2 times 10 minus 7, which is 13. And it works. If you want to write down questions 4, 5, and 6.